What's up? We are continuing talking about increasing and decreasing functions and using the first derivative. So just a reminder about what's going on here. Here's our test for increasing and decreasing functions. So if f prime is positive in our given interval, then that means that our original function f is increasing on my inclusive interval. Okay, if f prime is negative, that means that f is decreasing on my interval. And if f prime equals 0, that means that f is constant. Okay, now our first derivative test. So if f prime changes from positive to negative at our given critical point, that means that our critical point is a relative max. Or you could say local max, same thing. And if f prime changes from negative to positive, that means that my critical point is a relative minimum. Okay, so remember, this means it's going from increasing to decreasing. So I have a hill. This means I'm decreasing to increasing, which means I have a valley. All right. Now in our first example, they're asking us to find the interval where we're increasing and decreasing, and then find our maximum and minimum points. And we're given a piecewise function. We haven't done a piecewise function yet. All right, so let's take the derivative. And taking a derivative of a piecewise function, you just take the derivative one part at a time. So the derivative of 2x plus 1 is 2, where x is less than or equal to negative 1. And the derivative of x squared minus 2 is 2x, where x is greater than negative 1. Okay. So I know that this part is never going to equal 0. So when I want to know where f prime of x is equal to 0, I'm really only going to use this function right here, 2x. And I know that this is going to be 0 at 0. So I know that I have a critical point at x equals 0. Right? And this is fine because it's also within my given domain here. Okay, and upon further analysis, I realize that I have a critical point at negative 1. The reason why I have a critical point at negative 1 is because the function is discontinuous at negative 1. So remember, a critical point is where your derivative is either 0 or undefined. Okay, it can be both. So in this case, the function will be 0 at 0. It is undefined at negative 1. The reason being, if you plug negative 1 in, up here you get 2, down here you get negative 2. They're not the same, so the limit doesn't exist. It's discontinuous, and so it doesn't exist. Okay, so now let's make a number line. Boom, boom. All right, so I'm testing negative 1 and 0. And so if you just plug in a number smaller than negative 1 into my function, you'll get a positive number. Because less than negative 1, the function is always 2. My derivative is always 2. It's always positive. Okay, between negative 1 and 0, I'm going to be using 2x, and so you'll get a negative. And then greater than 0, you'll get a positive. And remember, you're plugging these into your derivatives, so right here. All right, so that means that my original function is increasing, decreasing, and then increasing again. So let's talk about where we're increasing. So I know that f is increasing. We could say, from negative infinity to negative 1, union 0 to infinity. We can say f is decreasing between negative 1 and 0. And remember, it's not a huge emphasis on whether you use parentheses or brackets here. I'm using brackets in this situation, but you've seen me use parentheses before. The AP test will not count you wrong either way. Okay, and then we are asked to identify our relative maximum and minimum points. So I know that f has a relative maximum at x equals negative 1 because f prime changes from positive to negative. All right, so it's going up and then down, so I have a peak right there. And I know that f has a relative minimum at x equals 0 because f prime changes from negative to positive. And that's enough justification for those. All right, let's move on. All right, so we're looking at the same thing here, but just in a different way. So we're looking at a graph this time, and this is the graph of f prime. All right, I'm actually going to write that a couple times just to remind myself. This is not the original function, this is the derivative graph. Okay, now we're asked to identify on which intervals is the graph of f, not f prime, but the graph of f is increasing and decreasing, right? And the way that we can tell that from our derivative graph is where we are positive and negative. So if f prime is greater than 0, or it's positive, then that means that my original function is increasing. If f prime is less than 0 or negative, that means that my original function is decreasing. So I'm really looking for the intervals where my derivative graph is above and below the x-axis. That's really what I'm looking at. All right, so let's talk about that first. Okay, so let's talk about increasing. I see that I am above the x-axis from -3 to +1. So I am increasing on -3 to 1, and then also from 4 to infinity. And then my justification would be because f prime is greater than 0. Okay, I'm decreasing whenever I'm below the x-axis. So it looks like I'm decreasing from -infinity to -3. And then I'm decreasing from 1 to 4. And my justification would be because f prime is less than 0. Okay, so I gave my intervals and I also gave where my justification. So it's relating to the first derivative. An important thing to note is that your justification should always include the information that you're given. So in this case, we're given the graph of f prime, so I need to justify my answers using f prime. Okay, now let's move on to B. It says estimate the values of x at which we have a relative maximum or a relative minimum. Okay, so remember, in order to have a maximum, f prime needs to change from positive to negative. To have a minimum, f prime needs to change from negative to positive. Alright, so let's see what that happens. I see at -3, I change from negative to positive. So this is a critical number, and it looks like I'll have a minimum here. And then I have another critical number here at 1, and I'm changing from positive to negative. And then I have another critical number here at 4, and I'm changing from negative to positive. Alright, so let's talk about my maximum first. So I know I have a relative max at x equals 1. My justification would be because f prime changes from positive to negative. Alright, and let's talk about my minimum. We'll have two of them. So I have a relative minimum at x equals -3 and x equals +4 because f prime changes from negative to positive. Right, so there's my justification, and here are my values. It's important to note that I'm stating where they occur. So it occurs at x equals 3. Okay, this is not the minimum and maximum values. Those are y values, and we would have to have an original function to have those. So this is as good as I can get. All right, let's keep going. All right, a bit of a weird example here. So I'm given that f prime is less than 0. Okay, so if we think about what that means that we're decreasing. That means f prime is negative. Yeah. On this interval, we're positive. On this interval, and then negative again. All right, so part A asks, if g of x equals 2 times f of x, what is the sign of g prime of -1? All right, so first let's define what g prime is. So we take the derivative, and the derivative of 2 times f of x will just be 2 f prime of x. Okay, so now I need to evaluate g prime of -1, which is just going to be 2 times f prime of -1. All right, so I'm going to look over here, and I know that -1 is less than 0. meaning that, oh, sorry, I know that -1 is between, -3 and 2, and so I'm going to be using this interval here, and it tells me that f prime of x is positive. So 2 times some positive number. Okay, I don't know what that number is. It doesn't matter what that number is because 2 times a positive number is still going to be a positive number. Right, so I know that the sign of g prime of -1 is going to be positive. Okay, let's move on here. Same situation, but now I have a composite function. So when I take the derivative, we have to use chain rule. So it's going to be f prime of 3x minus 5 times the derivative of the inside, which is 3. Okay, now when I evaluate at -1, this is a minus. So I plug in -1, I get -3 minus 5, that's -8, and then times 3. Okay, so I'm evaluating at -8, so I'm going to use this interval over here, because -8 is between -infinity and -3, and I'm given that f prime is less than 0. So I have some negative number times 3, which is going to be a negative number. And so that will be the sign of g prime of -1. Alright, let's move on to our last example. We're talking about particle motion. Okay, so we're given the position. Okay, so this says it describes the motion of a particle. S always stands for position. And first we're asked to find the velocity. So remember that the derivative of position is velocity. So we just take the derivative, it'll be 2t minus 7. And so my velocity function is 2t minus 7. Okay, so the next part is asking me to identify when the particle is moving in a positive direction. That really is asking for when my velocity is positive. So remember, the difference between speed and velocity is that velocity has direction. Okay, so if I have a negative velocity, that means that I'm moving to the left. If I have a positive velocity, it means I'm moving to the right. So this question is asking me for the time intervals in which the particle is moving to the right, or moving in a positive direction, or actually it could be up or to the right. Those are both common uses for this. Okay, so essentially all I need to do is figure out what my critical number is, and so if I set my derivative equal to 0 and solve, I'll get 7 halves. So I'll make a number line, 7 halves is my critical number. If you test any number less than 7 halves, you'll get negative. Anything over here is positive. Okay, so it's asking when the particle is moving in a positive direction, meaning I want this interval over here. So it'll be from 7 halves to positive infinity. And our justification would be because v prime of t, which is the derivative of my position, is greater than 0. Alright, so positive direction, positive, greater than 0. Okay, then it asks me to identify when I'm moving in a negative direction, and so that'll just be the other interval. So I can say negative infinity to 7 halves. My justification, very similar, because v of t, which is s prime of t, is less than 0. Okay, then it asks me to identify when the particle changes direction, and that's going to be my critical number. So it changes direction at 7 halves because my velocity changes from positive to negative. So if your velocity changes sign, that means that the particle changed direction. Okay, just like on a graph, if your graph takes a u, for instance, okay, right here at my critical number, the first derivative changed sign from negative to positive in this case, and so it went from going down to going up. And it's the same thought here for particle motion. So it was moving down, now it's going up. It was moving in a negative direction, now it's moving in a positive direction. Same deal here. So whenever your velocity changes sign, that means that your particle changed direction. Alright, so if you have questions, we can talk about that more in class, but that's it for today. See y'all later.